Hello and welcome to TidyX. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick. And both of us are on Twitter simultaneously
At the same time.
Tidy at Tidy_explained. Or you can shoot us an email, tidy.explained@gmail.com. You can take out an issue on the GitHub repo, or as always, if you can, hit like and subscribe on the YouTube channel and go ahead and leave us a question or comment. We got a bunch of comments, I believe, on last episode where we began the process of tackling Tidymodels, which is a new frontier for the both of us. As I said last week, everything that we've done up to this point has been in sort of the native language of whatever package we built models in. And so that led to lots of, work in terms of like redoing the pre-processing steps, finding the right model fitting code, and yada yada.
A lot of manual effort for us.
A lot of manual effort.
Yeah,
Herculean, some may say. So the goal is to step into Tidymodels in the hopes that we can take what we've done and make it a little bit more within a little bit more of a similar framework or construct for all of the models that we fit.
Mm-hmm. And simplify it so that it's just like a very easy to follow process for everybody. So let's get into it. Let's start. What are we doing this week, Patrick, as I share the screen so everyone can see what we're doing?
Yeah, so last week we just fit a basic model. We've talked about fitting a basic model in Tidymodels. This week we're going to go through each sort of piece of the framework one by one, and then each subsequent episode is going to kind of build on the framework. So this week we're going to introduce a few of the kind of core concepts of Tidymodels, things that make it really useful, things like how to set up a recipe and address data issues, which normally you'd probably do this just outside of any model building process. You'd sort of code in your imputations and your normalizations and your dummy variables if you needed them and all that kind of stuff. We're going to do that right within the Tidymodels framework, and then we're going to go into building a model and then kicking out some predictions, basically doing what we would call a train and test split on the data. We're going to do that within this Tidymodels framework so that, again, it's one less step that you have to do sort of outside of the model building process. We're going to try and keep everything contained, and we're going to be using the air quality data, which comes from the datasets library. So we'll load up our 4 key libraries there. Tidyverse, which is for our data manipulation and plotting. Tidymodels for obviously Tidymodels. Patchwork, which we'll use for a little bit of our exploratory data analysis and plotting, and then datasets to snag that air quality data set. And we set the theme to light, and we've got a few cool little plotting functions here that we've set up that are kind of our custom functions, because we're just going to be doing these things over multiple different variables. So it helps to build this. So we have a function where we basically pass it the column name of interest. And then within that function, we're basically taking our data set and we're saying on the x-axis, put whatever column we wanted to specify, and put the y-axis to be the ozone, which is what we're going to be predicting from the air quality data set. And then it's going to be a point plot. And then we're going to smooth over that with the LM function. And then for categorical variables, it's going to be pretty much the exact same thing. The only difference being that we'll do a box plot across the different levels of the category. And the 2 brackets there on the x-axis, those are going to help us basically help R say, hey, take that column name and make sure that's on the x-axis as a name. If we didn't put those in, the x-axis would just be called col, because that's all the function knows at this point.
Yep. Yeah, so it makes it simpler. And the reason we're doing this is because what do you always do when you start looking at a data set for the first time, Patrick?
Plot.
You always want to plot it.
Plot.
Yeah, actually, I saw a pretty funny thing on Twitter recently where people shared a data set with their students and told them to start looking at it and evaluating it. And it was actually a plot of a gorilla.
Oh yeah,
But
sure.
but they were asking you for you to look, or I forget what the actual scenario was, but it was like, I think it was hypothesis driven
Yeah.
analysis versus freeform, and the freeform students all plotted their data first, and were able to go to gorilla
Yeah, yeah.
and identify the
Plotting
issue.
is always a great, when you're starting out with the data set, and then even when you're done with the data, like we'll do in the end, plotting your model fits. Actually,
Exactly.
today, statistician Andrew Gelman, who keeps a nice blog called Stats Modeling, he posted some figures from a paper, and he said, well, clearly, even though this paper has been published, we can see that there's a problem with the model just by looking at the plots of the output from their model, from the
Dun, dun,
simulations.
dun. All
Yeah,
right, so let's get started. We're now 5 minutes in.
plotting tangent. Yeah.
So we've got data, which is going to load the data and attach it to our current namespace here. I do question mark air quality just so I can get a little bit of information about it. It's New York air quality measurements. It's got 6 different columns here. It's got the ozone, the solar R. So ozone is parts per billion, I think, ppb. Ozone parts per billion. Between 1,300 and 1,400 hours on Roosevelt Island. The solar R, wind, temp, month, and day of the month. So we're going to take that. What we're quickly going to do is we're going to convert month, which in this data set is just a numeric value. Month is a categorical value, or we're going to treat it as a categorical value. So we're just going to throw it as .factor on that so that it is treated as a factor as opposed to numeric. So that's why we're calling it month.f. And then that creates our df data set there. Take a quick head there so you can see ozone, solar R. So solar R is a solar radiation. Wind, temp, month, blah, 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 and month f, which is our factor version of months. So let's also quickly take a look to see if there's any missing data or anything weird that we should see in our data set. And we can see immediately, because hint, hint, here, we have some NAs in our data set here. So we have 37 records that have no values for ozone and 7 records that have no values for solar R. So this is something that there's a couple different ways you can handle this for modeling. You can just drop those records, which is a pretty common technique, or you can try to impute those.
Yeah. But dropping them in this case, if we have 37 missing, do an n row and let's see how much we'd be.
Is it na.omit, right? df. We'd lose. So normally it's 153, I think.
Yeah. So we're basically losing about 40 records.
Yeah,
right?
We'd be losing 42 records of data, which when we already have a very small data set is not great. So we're gonna impute that later, but we'll go over that. So let's do some quick EDA. So let's look at the n row. So yeah, like we said, 153 rows, and let's take a quick look at this plot. So what we're gonna do is we're gonna use patchwork to put these together. So we're going to plot continuous the solar.r column against ozone, wind against ozone, temperature against ozone, and then a box plot with the month, or a box plot of month versus ozone. And we're going to plot it so that it creates a nice little grid. So you can look at that, and it does look like there is a vague relationship between a couple of these things. Here or there. Like temp and ozone seem to be pretty nicely related. Wind and ozone, so the more the wind is going, less ozone.
That one is...
Solar R is a little bit less connected.
Yeah. Or maybe related. It's not even linear, right?
Yeah.
Kind of like goes up and comes down after about 290 or so.
Yep. And then here, ozone in the months of July and August look like they're a little bit higher than the rest of the months. But there we go. Now we have a quick understanding of our data and what's going on here. We can go on to potentially modeling it. So there's a bunch of different stuff that you can look at here. We'll share this code out so you can take a look at it. But let's get going with actually into the modeling.
Oh, yeah. Actually, this part...
Actually, we're not doing modeling.
We're not doing cross-validation either. So We have the note there that says.
Yeah, we're not doing that. Ignore that. Ignore us.
Yeah. Yeah. All right.
What we're doing is we're going to do splitting by testing and training. So you always want to be splitting your data into test and train so that you can reliably test your data or train your model and then see how it actually performs on potentially real world data. You don't want to be doing this back and forth a lot, though, because that would not be good. That would be information leak. So anyway, sorry, tangent. All right, but initial underscore split is the function that will split our DF, which is our modified air quality data set. And we decided we were going to stratify it by month F. So month F, if you remember, was that month factor because it looked like there might be some categorical information or it might contain some additional information. We wanted to make sure that we wanted to stratify by that so it didn't accidentally split and have 1 month just not included in the data or in the training or the test data set. So we stratified it by month F, and so that we end up with this sort of information here. So what we didn't include is the prop, which normally is included or it is defaults, I think, to
That's it right there, 3/4.
Yeah, initial it defaults to 3/4. So it's going to put 3/4 of your data in your training data set and 1/4 into your testing data set. And that you can see here. So 113 in your training or analysis data set, 40 in your assessing data set, and total is 153, which is the total number of rows in DF. Now, how do you pull those out? You use the training and testing functions included here. So let's pull out our training and testing data sets so we have these prepared, and we can go on eForth and start prepping our data. Patrick, do you want to take us through this?
Yep. So this is one of the cool features of Tidymodels is that most of these things we would normally do kind of on our own. Now we can do them within the workflow of our model building process. So we're going to create what's called a recipe. And the recipe, as the name would imply, contains the recipe of all the information that we want the model to be able to do. So the first thing that we do here is we're going to put in a recipe, which is basically our model specification. This is no different than if we were writing like a linear model or logistic regression model or random forest, whatever it is. It follows that same syntax, which is the dependent variable, the outcome variable on the left. So in this case, it's ozone, the tilde, and then basically our features or independent variables on the right of the tilde, and then comma, pass it the data that we're going to use, which is the DF train data, so it knows where it's coming from. And then we are going to pipe in this step impute median. So that's basically saying take ozone and solar, which remember we had some missing values, and we're just doing a simple median impute. Step has a whole bunch of different options you can use, of course, KNN and different things you can use. So linear regression type of things, but we're just going to do simple here. And then the other thing we're doing is we're just going to normalize all the variables. So basically normalize is going to z-score them. So put them on to a scale with a mean of 0 and standard deviation of 1. So each observation minus the mean of that column divided by the standard deviation of that column.
Mm-hmm. There's a bunch of steps that exist.
There's super high number of steps that exist.
Arrange, back impute, bin, boxcox, BS.
Step core will remove correlated, highly correlated predictors.
They've been the Tidymodels team has been thinking, what could you want to do to your data? Because we want to provide a tool to do it.
Yeah, so lots of options here, but we'll just keep it easy with median and normalized.
Yeah.
So now we have a recipe. Did we run the recipe
yet? Not yet.
Nope, not yet.
Let me run that.
If we run the recipe and we look at it, cool. Okay, so there we go. So we see we have one outcome variable. We have 4 predictors. That's what our model said. And the operations are that we're doing a median imputation over ozone and solar. And then we're centering and scaling solar wind solar, wind, and temp, right? Because, and those are the variables we gave it because those are the continuous variables, right? So we're not going to scale the month because it's a factor variable in our case.
Yep.
So now that we've got that, we are going to pre-process.
No, we don't. We don't do that.
Yeah, that's right. We had that for some reason. And we got rid of it.
That was when we were kind of messing around with stuff.
Yeah. So now this is what we did last week, which was we basically initialize a linear model. This is like, this doesn't do anything. It doesn't run the model yet. It just tells Tidymodels like, hey, we want to do a linear regression. We want to set the engine to LM, and then the set mode, we just set it to regression here, but you don't really need it for this one. We talked about that last week because LM is LM, right? If it was a random forest or a tree base, a decision tree, we could have a regression or classification and we'd want to specify that mode. But we'll just do it because it is good practice. So as you'll see, we run that. It doesn't run a model. All it does is say, hey, you've initialized linear regression, and now we're ready to get into the workflow. So Ellis, why don't you step us through that?
Sure thing. So the workflow is where you define, okay, this is what I expect to happen. This is the workflow that I expect to be following to produce our outputs. And so you initialize it with the workflow function. You pipe that into, and they have a series of different add functions here that you might want to use, but we're not going to use those because we're pretty simple here. We're going to use add workflow or add model, which is the LM model that we're going to be adding. And then we're going to say, okay, but also we want to pre-process our data before we throw it into the model. And so you need this add recipe function. And then you pass it the recipe that we just generated here. And so once we run that, we create this new workflow that it's describing how we'll be taking raw data that we'll throw into this, and then the model that the pre-processing that we'll be doing, and then the model that we'll be applying to it. And so this is like encapsulation of all the information on your data that you will want to be doing. And so it's like, it's all there. So it's actually kind of cool. So your preprocessor is this recipe, the model is a linear regression. We'll pre-process it by imputing the median and normalizing, and then we will run a linear regression using the LM engine. All right, now the way you train it is super easy. Haha! You take the workflow and you throw it into the fit function, and you specify the data you want to be training it on. And it's fit. It goes pretty quick because it's LM, and the manipulations we're doing to the data are not very crazy. But here you go. This is the coefficients here and the summary of the model. So not all that exciting, but we can also review the model. So what you can do is you can take that fit model, you use the function extract fit parsnip, and then you will throw it into a tidy because this is now pulling out the fit model. And we're going to throw it into the tidy there to make it look nice and pretty. And this is how you might be able to show your data. And so somebody sent us an email asking how I might be able to present this sort of information. I feel like this is a pretty solid way to do it. Just pull that out. Yeah. And then you can turn that into a cable.
Table or something like that.
Yeah. There you go.
There you go. Or you could use a formatable table or lots of options. Maybe we'll get into that. Making research paper worthy tables in R.
Yeah. Maybe we can end that with this.
Yeah.
And this series with that.
Yeah.
We'll see. All right. Do you want to take us through this now, Patrick?
Yep. So we've basically gone through all the process of fitting this model on a trained data set, and now we're ready to use those, whatever it was, 30 rows of test data set. So we're going to use the handy dandy predict function, which we've used a billion times here. We're going to do, so this is a bit tricky, and we were a bit perplexed here trying to mess with this. Mm-hmm. So it's something that if anyone's watching and sees what we're doing wrong, we'd be super grateful for a comment or on the YouTube channel or an email, and then we can amend that and of course, give you credit for it. Generally, when you run predict, you simply have to do predict, predict, and pass it the model, and then pass it the new data. And we were getting all sorts of errors doing that, even after baking the test data, which basically means we pre-prepped it with the recipe information. Mm-hmm. And so we figured we were going to have to do it like this. So basically what we did was we took the model fit and we extracted the fit using that little parsnip function there. So that basically gives us what the model coefficients are. And then we put a comma, and for the new data, we're basically saying take the model fit, extract the recipe from the model. So that's the recipe used to transform the data, normalize, and impute the medians, all that stuff. And we bake that recipe over the test data, basically saying, hey, use that recipe information and now apply it to the test data, because remember, the test data has some NAs and it needs some imputation and it needs to be normalized, right? Because all of our coefficients are looking at things in units of standard deviations. They're not looking at these variables in their normal units. Actually, it does look weird. They are. The coefficients do look strange.
Yeah. I think it's just a new set because we didn't set a seed.
Okay. So we can predict, run the prediction.
And we get these values.
And we get these cool little values.
I do want to show what it was getting, just so the tidy model, or somebody that knows better than us.
Yeah.
This is what we were getting. We were very confused.
Yeah.
Logical subscripts must match the size of the indexed output. Index has size 40, but subscript is NA. New data has size 0. Not sure what that means.
We kind of played around and couldn't figure out.
Yeah.
We tried lots of different things, none of which worked, obviously.
That also didn't make sense to us. So once again, Tidymodels team, we will probably be opening up an issue.
Yeah, anyone who can help us with that, that'd be cool, and we'll talk about it in the next episode. Mm-hmm. But we ran our prediction the way that we did it, and we basically then do a bind columns, and this gives us our ozone value and then a predicted value of ozone, and then we basically take those results and we're going to create another plot. So we're basically taking our test data that we've fit the model to. We're putting the predictions on the x-axis, the actual ozone observed in that test data on the y-axis. We're going to make them points kind of big, size 6. We want to color them by the month, the factor month. We want to set the alpha level to 0.5, so it's a little bit of a kind of opaqueness to it, kind of clearness to it, rather. And then we're going to set an AB line. So basically, this is going to be a line of equality. It has an intercept of 0 and a slope of 1. So a perfect prediction will lie smack dab on top of that line. If there's any bias in the model, we'll see the points that are going to be pushed all the way over to the right of the line or all the way over to the left of the line. And we're going to make it size 1.5, and we're going to do it dashed. And we run that. And there we have kind of our little circus colored dots, nice little dots. And we can see where the predictions lie relative to what was been predicted. We can see maybe there's a little bit of issue in our predictions because we have this spread that sort of gets bigger as you move from left to right. So to the left, it's a little bit more tightly wound along the line, and then towards the right, it's starting to fan out. So that might be something that we would have to look at within our model or figure out why, or ask other questions.
Look into it more, maybe pick a different model. Maybe this isn't just linear. Maybe there's
other
some
things,
interaction going on. Who knows?
Yeah.
Well, somebody maybe knows. But so this is how you can go and take a data set, pre-process it, fit a model on it, and then split the data, pre-process, and then rerun that same pre-processing on your test data set and see how it performs. And this is a very linear, very simple example here of how you might do that.
Yeah.
Cool. Thank you all so much for joining us on our second episode in our series of Tidymodels. If you want to see and have us want to see discussion and comparison between base R and Tidymodels here, watch the last episode, episode 77. And as always, my name is Ellis Hughes. You can follow me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can follow me on Twitter at OSPPatrick. The screencast is on Twitter at tidy_explained. It's also on Gmail at tidy.explained@gmail.com. You can go on to the GitHub repo and open up any issues there, or you can like and subscribe on the YouTube channel, drop a comment in. If you know about the problem, drop a comment in. We'll address it next time, and that'd be super cool if anybody watching can kind of help us out, because this is our first foray into Tidymodels as well.
All right. Thank you all so much, and keep on exploring your world.